All right, sorry about the background noise, but we're going to make the best of it tonight. And it's a little cold over here, so please mind a sweatshirt, but we are going to get into it. All right, tonight we're talking about adding, subtracting, and multiplying radicals. Okay? And when we're talking about those radicals, we're talking just, the square root, the cube root, so forth. X to the 1/2, stuff like that. Okay? So I'm doing this tonight, but it's going to be due on, we'll say Friday. That would be a good pace for you guys. I just know I have a busy, long day tomorrow, so I'm going to pump this out now. And that way it gives you guys time, too. If you guys have questions, you guys can ask. All right, so let's start this off with something you guys know. In order to add variables, what do we need? We have to have the same variable, and you have to have the same exponent. So we can add, we can subtract those. Like right here, we would have 2x squared, okay? If we had x to the third plus x, well, we can't do anything with that, so that's already simplified, okay? The same rule is going to apply when we're talking about radicals, okay? So first thing, we have to have the same index. Remember, in this case, it's 2. We just don't write the 2. And we have to have the same number underneath. So if I had the square root of 3 plus 4 square root 3, okay, well, in front here, there's always a 1. How many square root 3 do I have? I have 5 square root 3. Simple enough, okay? Same thing would go if we're subtracting. So if this was square root 3 minus 4 square root 3, now we have negative 3 square root 3. Okay? So same rules apply for adding and subtracting. Okay? When we are multiplying here, in fact, let's get into a little bit more here. So let's throw up an addition subtraction one that you guys are actually going to see tonight, or whatever day you do this. Negative 3 square root 12 plus 3 square root 3 plus 3 square root 20. And if you're reading along, this is number 6. Okay? All right. So what can we do here? Sometimes it's not about, hey, well, I can't do anything. Sometimes you got to look at it and go, what can I do right now? Okay, so let's isolate just this. I can break down that square root 12. And this is negative 3 square root 4 times 3 plus 3 root 3. Can't do anything with square root 3. Plus 3 root, well, I know that this is 4 times 5. Okay? All right, well, I know that the square root of 4 is 2. So let's go negative 3 times 2, square root 3, plus 3 root 3, plus 3 times 2, square root 5. Okay? So now I have negative 3 times 2. This is negative 6 square root 3, plus 3 square root 3, plus 6 square root 5. Okay, so right here I can't really do anything more with that, so this guy's just hanging out. These two over here, though, I have a square root 3 and a square root 3. I can and I need to combine these. So negative 6 plus 3, we're at negative 3 square root 3 plus 6 square root 5. And there's my answer. Okay, let's keep on going here. So we're also going to see ones that we can multiply. Multiplying gets a little bit easier here for the simple fact that, heck, we don't care what's underneath. So think about it just like when we had a variable, right? So if I had x times x squared, well, we have x to the cube. Okay, nice and simple. If I had x to the 5th times x squared, okay, this is x to the 7th. How many x's do I have? Okay. All right, well, we're going to take the same concept here. We're going to apply it to our radicals. So we have the square root of 6 times the square root of 2. Okay? You can do a couple different things here because we know that we're going to break it down. So this is the square root of 12. Okay? But you don't even have to do that because we're going to end up breaking this down anyway. So I would just not even put that in there because that's an added step that we don't have to do. I would come over here to the original and go, well, square root of 6 is 3 times 2. Okay? And I'm multiplying, and I have this, and here's the important factor. I have the same index. Okay? There's a way to do it without the same index, and we might get into that another day. I'll just double check here that we're not going to run any of those tonight. So we have the square root 3, square root 6 times square root 2. Okay, let's take that other 2, because remember, this is the same thing. We're just multiplying. We could put it all under the same one. 3 times 2 times 2. And the reason we can do that is because it's the same index. And remember that little 2 that we don't really write? Okay. If I see something twice, I can pull it out. So 2 root 3. There's my answer. Okay. Distributive property. Let's see. Okay, and here we go. Let's foil one time with y'all. Okay. Yeah, that's fine. Here we'll hit up 26 if you're going to look along. So we have 7 plus square root 6 times 1 plus square root 6. Okay. All right, so remember our distributive property, when we see these, I have a binomial times another binomial. I don't care what they are. I don't think anyone does. But at the end of the day, we have a binomial times a binomial. We know how to FOIL. I hope you guys know how to FOIL by now. Or you're going to take this first one, multiply it by those two. But let's FOIL. Let's keep it nice and simple. Remember this? First, outside, inside, and then last. Okay? I've seen some of y'all do it your own way, and that's fine as long as it works. Remember the rainbow method, same deal. Okay, but let's take care of this. So 7 times 1, 7. 7 times square root 6 plus 7 root 6. Square root 6 times 1 plus 1 square root 6. And then square root 6 times square root 6. And this is sort of neat because we go square root 6 times square root 6. Okay? And I use the word neat very, very loosely. Okay? Don't think I get like super excited over this. 7 plus, we have 8 square root 6 plus, what's the square root 6 times the square root 6? Well, if I do this, I see it twice. Okay, I can pull it out. And then I have to simplify it. So, final step, 7 plus 6, 13 plus 8 root 6. And when we do this, we put the real number, rational number first. Okay? All right. Hey, that's it for tonight, guys. Keep up the good work. If you guys have questions, okay? If you guys have questions, shoot me a message on Google Class. See ya.